We're still in chapter 2. We're going to look at a section called numerical summaries. And I am finally going to show you one of the tests that we use to tell if something's an outlier. You know, I've been promising that for a few days now, right? That is this 42, is it an outlier or not, right? How do we decide in a way that everyone agrees? And that is going to happen today with a bit of luck. So we are going to look at these 3 main topics. I'm not sure how much into 4 we'll get, but we will eventually do those 2. The first one is we're going to look at what are called measures of center. These are numbers that we use to tell what the typical value of some data is. And the 2 that are most commonly used are called the mean and the median, right? So we're going to look at those first. So I'm just going to randomly pick there. Here is a data set of 11 numbers. And, you know, from 1 to 29. Maybe these are all the people who are siblings in a big family, right? So somebody has 11 kids in these other ages, right? If you had twins. We're going to look at what the typical or central value of this data would be. Very often you will use the word, layman anyway, people aren't in statistics, just say the average age is, right? You know, my average test score. But when you use the word average, you're being a bit vague because there are more than one average. A mean is an average and so is a median. Let's do the one that we know how to do pretty easily. Since the data is the order, isn't the median 11, so halfway, 1, 2, 3, 4, 5, 6. That guy there is the median. And 1, 2, 3, 4, 5, 6. Do you see that in this case, the median is one number? Isn't that bang in the middle? So you would say in this family, the typical age was an 8-year-old, right? The middle of the family age group. So far, so good. Now, if you wanted to get what's called the mean, there is a symbol that we use for the mean. It's that guy. And to get the mean, don't you add up all the numbers? I'm not going to write them down because it would take too long, right? And divide by how many? And that's not too big, so I'm going to try it. It's going to be 1, add 3, add 5, add 2 7s, then an 8, then a 12, and then a 13, and then a 15, a 19, and we'll finish with a 29. So in this case, the mean would be a total of 119 divided by 11, and round it off to 10.8. So the mean would be 10.8, and in this case, the median is 8. Would you agree that there's no reason in the world why these 2 numbers should be the same, right? They're calculated in different ways. But it would be reasonable to expect that they're relatively, vaguely close to each other. Would you agree? If the median was 8 and the mean was 2,000, I'd be a bit worried, right? Something must have went wrong. These are the 2 most common measurements that we use to tell you what the typical value of a data set is, you know, the guy in the middle. And they all have strengths and weaknesses. And let's talk about the strength of the median. One of the strongest things about calculating the median is that it is unaffected by outliers. Do you see this 29 that I've got there? Isn't that relatively bigger than any other number? It might even be an outlier, right? But that 29 had no real significant effect in the median. Suppose somebody was 129, it'd be a miracle if there's anyone in the world that age. But if there was somebody that was 129, wouldn't the median still be 8? Right, it wouldn't be affected by it. Yes.
I thought it would be that it would move up. Wouldn't it be 12 since that? Then
oh, I'm I'm not keeping the 29. I'm replacing it by 129.
Oh, I see.
So if I replace it by 129, would you agree the median doesn't change? Right?
Yeah.
That's the strength. Medians don't get affected by outliers. Aren't outliers really big numbers or really small numbers? On the other hand, if I had changed this one, right? If I replaced this 29 with 129, right? So this 29, if I replaced it by 129, will you trust me that this thing here would have moved by an extra 10? It would be about 20. And that was just one number has an overwhelming effect. Can you see the outliers affect the mean, right? One big outlier will make the mean much bigger than it should be. One very small outlier very often affect the mean by making it smaller it is. Can you imagine you were doing all your averaging out your 8 tests and one of them was 0 because you had the flu that week and you couldn't do it? Wouldn't that 0 have a big ding on your average? Even though the others were all 80s, couldn't that 1 0 make your average down to 60? Right, just
Yeah.
because the influence that it has. So that's outliers is a strong point for medians, right? They don't get affected by it. Outliers are a negative for the mean.
Oh, I was gonna, sorry, I was, so
No,
I know
keep
that's
going.
one of the reasons why median is, it's useful for dealing with usually income, since if there's 50 people in a room and then Jeff Bezos walks in, the income is only gonna shift up like relatively slightly.
Yes. So that's a good example. That's one I normally pick Bill Gates, but Jeff Bezos will do exactly the same, right? Almost all government data that you look at that's summarized, they use the median instead of the mean. So they talk about the median income, the median house price, the median age of cars, all sorts of things like that, because we found that that's a much better measure of the typical age of a car or the typical income of someone. If you did, let's do that example. Does Jeff Bezos, does he live in Washington? I know Gates does, right? So at least
Probably has houses in Washington.
Right, okay. If you, for instance, decided to figure out what the average, right? So the average could be either of these two things. What the average income of people in Washington state was, right? There's only about, 5 million people in Washington state, roughly. Can you imagine what Bill Gates and a Jeff Bezos, when you add their money into that mix, won't Washington state look like, we're all half millionaires, maybe even a millionaire, right? Because if you can take, whatever, I don't know how much they have, 200 billion each, right? Well, you divide that amongst, 5 million people, it's still a lot of money, isn't it? So we don't like the mean for that reason. So let's turn it on its head. What's the advantage of the mean compared to the median? Well, one of the main advantages of the mean is, doesn't it use every single number in its calculation? So in a lot of ways, that's much more inclusive. In fact, we almost always, it sounds like a contradiction, but we always use the mean in statistics. And that's because we can do a lot more things with the mean, right? We can use it to make predictions that you can't do if you use a median. We can use it to estimate what we think is going to happen based on very small samples. And the mean is the go-to guy because it uses all the data. And so we like it for that. That's its main use. Forrest.
I was just gonna, also, I believe it's useful for, with the mean for population stuff, it can be useful if you're calculating things where it matters if it's something where you care, if an outlier, sorry, it's like sorry, I need to get my thoughts in order.
I hear you. Yeah. I mean, if you want to use all the numbers in the data because every single number, including the outliers, are important, then the mean is going to be a much more useful way of doing it because it uses the outliers values like everyone else.
I was going to say it's useful for calculating things where like damages from floods, where it is important or to know if most floods only cause a couple thousand in damage, but one causes $1 billion in I'm making those numbers up.
Yes, that
you'd want to know that if you're an insurance
not
company.
to ignore. Yes. Yeah. So are we cool? No, are we cool with the mean and median? How you calculate them, right? And they have strengths and weaknesses. Now, there are going to be some situations where.
But what if the median is 2 numbers? How do you find that?
Oh, well, if it's halfway between 8 and 10, you just add them and divide by 2. So just for argument's sake, pretend the median was, 2 numbers, those 2, right? What you would do is you would add them and half it, and the median, if that was the case, would have been what? In this case, it would have been 10. Right. So yeah, that will happen. So suppose there's just a lot of numbers and they're all jumbled up, especially. Isn't the median quite difficult to do because don't you have to put them in order before you can even figure it out? Now, if it's 8, 9, 10 numbers, it's not a biggie. But if it's 30 numbers, aren't you getting to the point where you don't want to do it? Right? It's just too much time. So what I'll try and show you now is how you can do this on your calculator. And then I'll go and I'll show you that you can also do it, at least in some questions, you can also do it in SALT. Right? So when you're doing your homework, you can save yourself some work. So let's do it on the calculator. So I'm going to hit the wrong button there. I'm going to hit start. Choice number 1. I should write these down, shouldn't I? So the first thing you do is you choose the start button. Then you choose option 1, which is edit. And you press enter. So we've done a lot of this already, at least once before. So enter. And I'm going to delete all these numbers because that was this the one that we did where we got everybody's age, wasn't it? You see it? Right. So I'm going to put the numbers that we now have in. That's 1, 3, 5, 7, the twins, 8, 12, 13, 15, 19, and finally 29, right? So there's all the data in. That wasn't too long. And so you, L1, you fill in the data. And then you hit start button again. And you press enter. Guess you don't need enter, but sometimes you do. And then you move over, right? You move over to the calc menu. And you choose number 1, which is called 1 var stats. And you press enter. And then you type in L1. To get L1, it's blue button. So in my case, it's second, number 1. Okay, and then finish with enter. Now, if I've done this correctly, shouldn't the median be 8 and the mean by 10.8, right? Agreed? Now, if it's not, it just means I didn't do this right. Okay, it means that this is correct. So here goes, enter. Now, can you see the 10.8? You see the funny little X bar, top row? Right? It might make life easy if they wrote down the word mean, but they use that funny X bar symbol. That is the mean. Now, if I scroll down, can you see the median is 8? And don't you get an awful lot more stuff? Don't you get what's called the 5-figure summary, which we'll be using a lot today, right? Not too painful, right? Pretty easy to do. We cool? Right, now let's nip over to the homework and see if I can find, darn it, in space, I hit the wrong button. If you bear with me for a few seconds while I get the right window open again. Right. Let's click on this one. Oh, before I do that, are you watching Cengage's website? Is that what you're saying right now? Okay. If you're not used to this, let me show you a couple of things. If you hit past assignments, you see these guys here? See how it says request extension? See those things? Well, you not hit those buttons because I had one person and it was more by luck than design. I was going in here doing something else and then I found out that they had sent me a request for an extension. And if I hadn't, by just sheer luck, being here and I saw the message while I was in doing something else, I wouldn't even have known that they'd asked for it. So when you need an extension, just email me. Just remind you, right, email me at drobertson and things are fine. Right, now if you want to see old homework, that's where it is. I'm back to current assignments. Let's click on this guy. And here we go. So here are some questions. We'll get into that later. I'm trying to find a salt button if I can. Oh, here we go. Right, here is a big ugly set of data, right? Imagine you were being asked to find the 5-figure summary or the mean or the median, right? Things that you need to do calculations for. I don't know. Let me try this. Okay. Are you still looking at that question? Right, good. Right, now what I did is I hit use salt and I did it so that I could get a separate window. Now, what you're looking at here is that data. Do you see it's all written down? Right. Now, what I'm going to do is I'm going to hit descriptive statistics. Do you see that menu there, the same one? And there's the mean. And there's your median. And isn't that where all the other stuff that you might want? There, for instance, there's your 5-figure summary. Can you see it? The last 5 digits. And if it's got a salt button, isn't that the best way to get your answers? The quickest. If it doesn't have a salt button, aren't you going to use your calculator? Unless the data set is like 5 numbers, and then won't you probably do it by hand then, right? So I'm giving you options of the most efficient way of calculating those things. Are we good so far? So let me stop sharing for a minute. Close that guy off. And we will return. So what I've covered right now is basically just number 1, measures of center, right? How to calculate them, doing nothing else except that, right? Do you feel comfortable if I gave you a list of numbers, you could get the mean and median, either by hand, using the TI-84, or the salt button if that was convenient. So
Are we going to be doing mode?
Mode, I'll tell you about it, but once I tell you about it, I'm never going to use it again. So here goes. The mode is the most popular number in your data set. So if you've got 8 number 7s, that's your mode. The mode is virtually never used by anybody for anything, except for, yeah, I know, you know, except for maybe categorical data, like what's the most favorite, what's the most popular color, right? That would be the only time I would use mode, right? Or if it was, you know, voting for the movie of the year, right? Which movie had more votes than anybody else? That would be a mode, right? Now on to 2, we're now going to look at a different number. A measure just means a number. And we're going to do a number that measures what's called the spread of the data. And there are 3 of those. There's one called the range. There's a second one called IQR. Well, actually, that's an abbreviation. That's what we normally call it, but its real name is interquartile range. But we call it IQR for pretty obvious reasons. And the third one is called the standard deviation. So far, so good. Right, that's the three main types. Before we get into the details of how you calculate them, let me give you an example of why having a number that tells you how spread out the data might be a useful thing.
What's the last one? Okay.
It's called standard deviation.
Deviation.
I'm going to give you two examples of why knowing how spread out things are can be helpful. I want you to imagine we've got two people called A and B, and they both play golf, right? And the first guy, right, has a mean of 80 shots. And the second guy, his brother, also has a mean of 80 shots. So in other words, when they play a round of golf, it takes them about 80 hits of the little ball to go around the course, right? That's just all that means. Now that's an average, right? You know, you play on Tuesday, he does 82, but he plays on Wednesday, he does it in 77, right? Isn't that what normally happens? You don't always get 80 just because the mean is 80, right? Isn't the 80 the typical number in the middle, right? But imagine, I'll draw it visually, that this is what the last 20 games look like. That's the first golfer. His average was 80. But one game he played out his skin. I mean, everything went right. All the bounces went right. The wind blew it the way it shouldn't have, but it was great because it was what he wanted. And he got a 70. And then one of the games he played, he got a 90. But wouldn't his average still be 80? And this is the second golfer. A in the middle, 78 and 82. Can you see that the mean of that one is also 80? But isn't that golfer Mr. Consistent? Right? He can play in a hailstorm, he can play in the snow, he can play when it's a gorgeous day. Doesn't he get 78 to 82? He gets an average about 80, give or take a couple of shots, right? Wouldn't you call that guy Mr. Consistent? And isn't this Mr. Inconsistent? If you're playing against this guy, won't sometimes he have a great game and you think he's almost a pro, and the next day you're thinking, this guy's wasting his time, right? He's played so badly. Now, that is just a nice piece of information. Here's another story. You're the manager of a basketball team, and you're playing a team that's really hard for you to beat, right? You know from previous experience, you know where they are in the league, and you've got a choice of two players, right? Two game winner players, right? You can play one or you can play the other, but your strategy is you're just going to play one of them most of the time. And here are the two guys that you're going to play. The first one, I'll use that symbol. He gets a mean of 30. And so does that guy. So when you play him, you'll get about 30 points out of him, right? Good player, right? One of your star players. If you play him, you get 30. But you know that that's not enough. You know that if you play that guy and he gets 30 points, you'll still get beat by about 15 points, right? But I tell you that this guy, right? He's Mr. Consistent. when you play them, you get 28 to 32 points a game off them, right? You play them this week, you'll get 31. You play them next week, you'll get 32. You play them the next week, you get 28. But he's pretty consistent, right? So here is a reason why sometimes you want Mr. Inconsistent. If you played this guy, do you notice what happens when he gets them? You might even know some players like this. It'll drive you crazy if you know them and if they play for your team. If you play this guy, couldn't he play out his skin and get you 50 points? Couldn't he have a stinker of a game and he only gets 10 points, right? He misses everything, even the obvious ones. Yeah, you know, Mr. Inconsistent players like that. If you're playing a really difficult team, one that you know you're probably going to get beat, should you play Mr. Consistent or should you play Mr. Inconsistent? There's one choice that makes more sense. Who would you play if you know that you need to get a lot of points, if you're going to win at all? Yeah. Aren't you going to play?
Depends on if the consistent person has enough points.
Yeah, and I've told you in my story he doesn't. Right, you need a lot more than 30 points if you're going to beat this team, right? You need to get about 45 points to beat this team, right? That's your prediction. Now, can you see that this guy, at least some of the time, won't he get you 45 points or more? So when you play him, it's a risk. Is it the risk he has a stinker game? But if he has a great game, couldn't he be the game winner for you? Have you never seen teams that normally you could bet 9 times out of 10, A is going to beat B, but team B has one of those great days and 1 or 2 players play fantastic games and they win, and people think, what on earth is going on there? Well, maybe what's going on there is just you've managed to get Mr. Inconsistent hitting a good game. So knowing how spread out the data isn't that a useful piece of information? Because knowing just the average doesn't tell you the whole story, does it? How spread out they are is also just as important if you want to make decisions based on that.
Called range then? Is this range?
Range is one of the measurements of that, yes. There are actually 3 numbers that do the same job. One is called range, one is called the interquartile range, and the third one is called standard deviation. So let's show you how you calculate those guys, right? First one is range. And its formula is basically, I was going to call it biggest, but I'll call it largest. So it's the largest number, take away the smallest number. So if you collected some data, right, like this guy here, right, he was 70 and he got 71 and he got a whole load of other stuff, and there was an 80 here and he got an 83, and then he finished with an 88 and then a 90, right? Can you imagine these dots had other numbers? Then in this particular case, the range would be 90 take away 70, right? The largest number, take away the smallest number. And in this case, the range would be 20. And if you were doing the second guy, wouldn't the range be the biggest number, 82, take away the smallest number, 78, is 4? Do you see Mr. Inconsistent has a really big range of 20. Mr. Consistent has a much smaller range of 4. You see how it calculates? Biggest, take away the smallest. Has advantages. First advantage, isn't it dead easy to calculate? Because don't you just need to know the best and the worst? You don't need to what's going on in the middle, right? Tell me the biggest, tell me the smallest, I'm done. Its biggest disadvantage is, don't outliers affect the range really badly? Aren't the outliers going to be here and or here? Isn't that where the outliers, if there are any, isn't that where they live, right? Can you imagine you could get data that looked like this? 1, 2, 2, 3, 7, 101. Right, would you agree that is an outlier times 2? That is a whopping outlier, right? But according to that very small data set, isn't the range 100? when you look at the original data, does that data number, does that really reflect what most of the numbers are? Would you agree most of the numbers are between 1 and 7, right? Do you see how the outlier affects it? And that's typically why we never really use the range much. It's too susceptible to damage, right? It's too easily affected. The second measurement of how spread out the range is called the interquartile range. And you get that by doing Q3 take away Q1. Now, remember the 5-figure summary, right? The minimum, Q1, the median, which is also sometimes called Q2, Q3, and the maximum, right? So to get the interquartile range, you don't need to know all these 5 numbers, but very often as part of the question, you get it. So I want you to pretend that I had a whole load of data and it looked like this. That was 1, this was 7, this was 15, this was 32, and this guy was 70, right? So suppose I gave you that 5-figure summary. The interquartile range is Q3, which is 32, take away the value of Q1, which is 7, and the answer would be 25. Would you agree getting the interquartile range is just a matter of taking these two? Now, if you were doing what you remember those little box plots that we just touched on that looked like that, remember those guys? If you want to know what the interquartile range is, the interquartile range is that distance there. It's how big the box in the middle is. See, if that box is really big, won't the interquartile range be a big number? And if that box is quite small, won't the interquartile range be quite a small number, right? So if these are close to each other, then the interquartile range will be a small number. And if these are quite far away, then it will be a large number. So as long as you've got the 5-figure summary, won't you be able to get the interquartile range? Now, the third one of the two, called the standard deviation, I'm going to hold back on that for a while because we don't really do it much until another section. I'm not sure I'm even going to talk about it today because it might be a distraction. Let's just focus on interquartile range in the 5-figure summary now. Right, that's where we're going to do most of our looking. And I want to show you the test. Remember we had, is this number an outlier or not? Remember the issues that we kept on having where Cody thought it was, and I shook my head and said it wasn't, and then we all agreed to disagree, that we both could be right. It was a matter of opinion. You feel, you know how uncomfortable that is. Can you imagine mathematicians don't like that? So statisticians basically created a test for what is an outlier. And I'm going to show you how that works. I'm going to start with a 5-figure summary again. So imagine I collected some data. And I have the 5-figure summary. And imagine the data looked like this. It was 1, 17, 18, 21, 27, 38, 92, right? So I had a whole load of data, right? A big chunk of data, dot, 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 because there's a lot of numbers in there, right? And it started at 1 and it finished at 92. The candidates for being outliers are always going to be the extremes. So would you agree that that one there might be an outlier and that 92 there might also be an outlier? Agreed? Now, I'm going to put Cody in the spot. Cody, you're watching this data set? I'm picking on you. That number there is 38. The next number is 92. What's your gut feeling? Is 92 an outlier?
Yeah.
I agree. Would you agree that's just so scarily big? It better be an outlier, right? Now, I'm not so sure about this one. In fact, now that I'm not so sure, I'm going to make it 10, right? To be even less sure. Right, Cody?
There's not a minimum number to be an outlier or not, like 1 to 20 is an outlier, but 1 to 15 is not.
No, I wish.
That's
Not,
weird.
not the way you, at least the way you, I'm hearing what you're saying. Here's the other side. That's 10, right? The next number is 17. What are you going for? An outlier or not?
No.
All right. I'm going to go yes, just to be different. Just to be different, because I probably would agree, right? But do you see we have a difference of opinion sometimes, especially when the numbers get really close to the next number, right? So what is the test? Well, let's put in the values. I know that's 10, right? I know that's 92. Can we pretend that that is 18? That's 32. And this is 37, right? Just for argument's sake. So with a whole load of numbers, but this is our 5-figure summary. First thing you do is you calculate the IQR. This is the test. You calculate the IQR. So it's Q3 take away Q1. It is 37 take away 18. And I believe the answer is 19. Are you comfortable about how to calculate IQRs now? It's just a formula, Q3 take away Q1. Now, step 2, you get a guy called the upper fence. That's his name. And the upper fence is Q3 plus, I know it's a bit weird, 1.5 times the interquartile range. So Q3 in this case is 37 plus 1.5 times 19. I'll do that in my calculator then. 37 plus 1.5 times 19. And the answer I get is 65.5. So far, so good? 65.5. We calculate the upper fence. Now here's the test. If your largest number is greater than 65.5, then it's an outlier. Which I now think I know what you were talking about, Cody. It's not any the way you said it, it's just I'm not that bright. You were saying, oh, is there a rule like if it's between here and here, it's an outlier, right? You phrase it like that. Do you see that's kind of what you were saying there? If it's bigger than this number, it's an outlier. Now, is 92 bigger than this number?
Okay, so you find the upper fence to find the outlier.
Yes.
Oh, that's cool.
Right? And that number never moves, right? That's the upper fence for this data. Now, how about to get the other side, right? Because that's how you test for outliers that are big, right?
Well, then you just subtract 1.5 divided by the IQR.
Kind of. Let's show you. Right. So if you want to get the lower one, the formula, right, is called the lower fence. Not surprised that that would be its name. It's Q1 take away, like you said, 1.5 IQRs. But you notice it's Q1 this time, right? In other words, it's 18. 18 take away 1.5 times 19. And that's going to be 18. I guess I shouldn't have done that, but too late now. 18 take away 1.5 times 19. And so in this case, the lower fence ends up being negative 2.5. So that means the following. Can we pretend that these numbers are temperatures? Right. So if your smallest number is lower, right, smaller If it's lower than negative 10.5, then it's an outlier. Does that make sense? So what about 10? Would that be an outlier? Nope. In fact, wouldn't 0 not be an outlier? Wouldn't you have to be well into the negative numbers, right? The negative, like a negative 20. Wouldn't negative 20 be an outlier? Can you see that it's a pretty difficult thing to be an outlier? Have you noticed that the way this test works, don't you have to be significantly big or significantly small, right? Meaning like massively big, massively small, before you would be considered an outlier. Now you might say, well, what about 10? Well, you could say 10 is smaller than normal. Couldn't you phrase it like that? But it's still not an outlier. It's just smaller than normal, right? That's all it is. You could even, if you want to say, it's extremely small, but don't use the word outlier, right? Because it's not an outlier, right? An outlier is exceptionally small, right? Exceptionally big, right? So we keep those titles like for the world champions of numbers, right? You know, the really, really big number that beats everybody, that kind of situation. Don't know if that's a good analogy. Do you like the test? Does it make sense that that's how we do it? If you're wondering where do these, why is it 1.5 and not 2? Why isn't it, some other combination? It was simply done by the statisticians in the world essentially got together and says, look, we're having a lot of argument, right? I keep arguing with Jody all the time. He thinks it's this and I think it's that, and I'm fed up. We both want a rule so that we'll all agree that we will use the term outlier only if this happens, right? And so they got together, and I'm pretty sure I can't prove it, but I'm pretty sure they tweaked it a little bit. They said, how about putting 2 in? Well, nah, 2 is, if you make that 2, almost nothing's an outlier, right? You very rarely get one. Okay, we'll make it 1. If you make it 1, too many things end up being an outlier, right? You want to keep it special, right? So I guess there was a sweet point at 1.5. Right? Made that up, but does that make sense that 1.5 would be good, right? And that's how they did it. So far, so good? Right. Goodness gracious. Look at the time. Okay. The next thing would take too long, so while I'm getting a little thing sorted out here, can you put your last name down for attendance, and I'll tell you some things and we'll finish. So last name only for attendance. Let's get that done. Okay, looks like the last 1 or 2 of you are kicking in. Right. You all did your test. Hopefully you all did your test. And make sure that, and you're going to look at it and you won't find it. It's not there. So it won't be there until about Wednesday. I go and I look it over and I check that WebAssign's been generous and fair. And I change the score if I think it hasn't. Give you an example. Suppose the right answer was 10.123 because it says give the answer to 3 decimal places. But you typed in 10.1234 because you wrote it down to 4 decimal places. Do you know WebAssign is really nasty and it would probably say wrong because that's what WebAssign does. So I fix that and I say, well, okay, she or he never quite did it, but I know that they did it right. And so I just go in and give you the points. So that's why I don't show you it right now, because sometimes you'll see your grade, I'll call it the raw grade, and you'll get a fright and you'll say, I only got 70 and I thought I'd done really well. And then I go and I check and 2 of the questions were just simple things you did right, but WebAssign was being a pain and you end up getting 90, right? So you can see the difference that could make to your score. So that's why they get hidden. Also, it stops you doing the test after it. So come Wednesday.
Is that the same issue of what I brought up to you, what WebAssign was doing with the... Yes,
that's an example. WebAssign was being really weird about rounding off some of the numbers in the, the stem and leaf questions, right? There was, I can't remember what it was, but it was some like 4 should have been, no, it wasn't 4, it was 15 should have been 20.
Because the fifth, because it, yeah, it did on the.
Yeah, it
stem
rounded
leaf,
off 5s in,
Yeah, rounded off
for
down.
want of
not
a
up.
better way, a unique way. So 45 became 50 or 45 became 40, right? It did something weird like that. And that was bugging the heck out of it. That would be an example of it. And I have no idea why it did that. I still don't know, but these are. So that's what I wanted to tell you, right? So you won't see it yet. In case you missed it during this, when I did the syllabus, tests do not get extensions. So if you haven't done the test, that's it. You get to drop 2 of them, so that'll be 1 of them probably. If you did really bad, you get to drop it as well. Hopefully that's not the case. And that is it. Bye-bye for today.